To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So you can remember in the previous chapter we discussed what electrolysis is. So there we supply current and make a non-spontaneous reaction to take place. And when we say lysis, normally there is a complex substance that is broken down into simpler components. That is the meaning of lysis. And that is done by supplying electricity. So therefore it is electrolysis. And electrolysis is carried out in an electrolytic cell. And also we discuss some of the examples for electrolysis. For example, you can remember electrolysis of acidulated water, then electrolysis of copper sulfate. In all these, you also want the observations are. And you can remember here we use similar electrodes, or it can be different when it comes to industrial processes. When you have the different electrodes, based on how they are connected to the dry cell, that is the battery, the electrodes become charged. So what is connected to the positive terminal becomes positively charged, and the electrode that is connected to the negative terminal becomes negatively charged. And from the solution, that is the electrolyte solution, the ions, the positive ions or the cations migrate towards the negative electrode, whereas the anions or the negative ions migrate towards the positive electrode. And there what happens? Usually, the positive ions take up electrons and undergo reduction. Therefore, the negative electrode is the cathode. And near the positive electrode, the anions or the negative ions lose electrons and get converted to another species. So there it is oxidation. So therefore, the positive electrode is the anode. So you can remember that. Positive electrode is the anode because oxidation takes place there. And the negative electrode where the reduction takes place is the cathode. So that is how the electrolytic cell functions. Today we will look at the different applications of electrolysis. So here you can see electrolysis process is frequently used in the manufacturing of various industrial products. So that is what you need to remember. Here we use it for the manufacture of various industrial products. And we will be looking at some examples. So some examples are given below. So if we look at the examples, now you can remember the activity series, students. Can you all recall the elements there or the metals there? We have potassium, sodium, calcium, magnesium, aluminium, zinc, iron. Then we have tin, lead, hydrogen, copper, mercury, silver, then platinum and gold. In that, the metals that are at the top of the activity series, they are the most reactive metals. For example, potassium, sodium, calcium, magnesium, these are very highly reactive. And you can remember those metals are extracted using electrolysis. So one application of electrolysis, especially in the industrial application, is the extraction of metals. And as examples, you can remember we have discussed this also before, extraction of sodium from molten or fused sodium chloride. That is an example. Then there is another process where we can extract aluminium from its ore, that is known as the bauxite. So those are examples of extraction of metals. That is one application. So one application, extraction of metals. And their example, first one we can say extraction of sodium from fused sodium chloride. Then we have extraction of aluminium from bauxite. You are familiar with ore, students. Now when we discuss extraction of iron, we discuss hematite. That is a mineral where a particular element is present in higher percentage. So hematite is an ore of iron. The same way bauxite is an ore of aluminium. So from bauxite we can extract aluminium using electrolysis. Then sodium chloride, you can remember we get it from seawater, salt. So that sodium chloride is in the form of solid. It has to be melted so that we get the fused or molten sodium chloride, that is sodium chloride liquid. From that you can extract sodium. That is one application of electrolysis. Then you can remember, students, we can electroplate metals. Electroplating of metals, that is another application. So here we can consider electroplating of metals. As examples, what can you remember? Now when we started off the lesson, we discussed how gold is cleaned. There are gold jewelries where you get them cleaned using electrolysis, or else the process of gold plating something, gold plating other metal objects. So that is an example of electroplating of metals. So here as examples we can say gold plating metal objects. That is an example. Then there are objects made up of either iron or steel. Now you all know steel is an alloy of iron, but still there is a chance that they can undergo rusting. So iron objects or steel objects, they can undergo rusting. Iron is more prone to rusting, but steel also sometimes can undergo rusting. But in addition to that, to get certain desired properties that are more useful, what we do is we either plate nickel or chromium onto iron objects or steel objects. So that is also an example of electroplating of metals. So here we have plating chromium or nickel on objects made of steel. That is another application of electrolysis. Then we already discussed that we can extract metals using electrolysis. In addition to that, now if you have metals that have already been extracted, but there is a certain amount of impurity, then to purify that metal also we can use electrolysis. For example, copper is extracted from copper ores. After it is extracted, there can be impurities. So to remove that impurity, we can use electrolysis. So that is also another application. And this removal of impurities is called refining of metals. So here, refining metals. So there we can say after copper is extracted from its ore, the impurities are removed from copper. So this particular process is known as metal refining. So here we have looked at 3 applications. One is extraction of metals, example extraction of sodium from fused sodium chloride, extraction of aluminium from bauxite. Then there is electroplating of metals. There are gold plating metal objects and plating chromium or nickel on objects made of steel, and also refining of metals. Refining metals, after copper is extracted from its ore, the impurities are removed from copper. In addition to that, there is another application that also we have looked at, the electrolytic process, manufacture of sodium hydroxide, that is caustic soda. You can remember when you electrolyze sodium chloride aqueous solution, then we get sodium hydroxide as one of the products remaining in the electrolytic cell. So manufacture of caustic soda. Manufacture of caustic soda, or what is sodium hydroxide. Sodium hydroxide. So this is another application. Here of course we use a method called diaphragm cell method. So this is done by using a diaphragm cell method. That is another application of electrolysis. Manufacture of caustic soda or sodium hydroxide, diaphragm cell method. I am sure you all can understand these different methods. So with that students, I will move on to the next slide where we will be discussing some of these applications in more detail. Right. So first we will look at the industrial production of sodium metal. Now just to recall what we have discussed before, you can remember students. Now we have the electrolytic cell with the electrolyte solution, the electrodes. So here we have the electrodes. Now since these are the positive and negative terminals, here also they become the positive and negative terminal. So if this is fused sodium chloride, that is molten sodium chloride or sodium chloride liquid, there are only 2 ions, Na plus and Cl minus, both in the form of liquid. So there what happens, the chloride ion, that is the Cl minus ion, migrates towards the positive electrode. So you can remember that Cl minus liquid comes towards the positive electrode. Same time Na plus liquid migrates towards the negative electron. So here Na plus takes up electrons and becomes Na liquid, sodium liquid. At the same time, what happens to chloride ions? You can remember Cl minus, 2Cl minus liquid loses electrons and becomes Cl2 gas. So this is oxidation and that is the anode. Here this is reduction and that's the cathode. Reduction, cathode. So you can remember all these. We discussed this when we discussed the different electrolysis processes. So this is electrolysis of fused or molten sodium chloride. Only 2 ions are there. So both of them migrate towards the respective electrodes. Chloride ion, since it's a negative ion, migrates towards the positive electrode. There it gets oxidized, losing electrons. So therefore, positive electrode is the anode. Whereas the Na plus ion migrates towards the negative electrode where it undergoes reduction by taking up electrons, and therefore it is the cathode. So you are familiar with this process. So if we rewrite the reactions again, I have explained what happens there. So here, fused sodium chloride is electrolyzed using carbon electrodes. So that is again something you all have to remember, students. Here it is fused sodium chloride and we use carbon electrodes. The following reaction occurs at the cathode in this process. So first reaction, cathode. That is the reduction of sodium ions. So you can remember that. What happens there? Na plus liquid takes up electrons and becomes Na liquid. So this is the reduction taking place at the cathode. The reaction occurring at the anode is as follows. What was the reaction? Chloride ions losing electrons becoming chlorine gas. So there we have 2 chloride ions, that is also in the form of liquid, becoming Cl2 gas by losing 2 electrons. So that is the first equation. This is the second equation. Now you all know when we need to balance the equation, when we need to get the cell equation. Now these are the half reactions. Cathodic half reaction, anodic half reaction, or ionic half reactions, or what we call as half cell reactions. So this is the cathodic half cell reaction. This is the anodic half cell reaction. When we want to get the complete cell reaction, we need to add them together. But before doing that, we have to make sure that the number of electrons are equal. So here there is only 1 electron. Here there are 2 electrons. So what do? This is the first equation. We need to multiply the first equation by 2 so that you get equal number of electrons. So when we do that, we get the overall reaction. We multiply 1 by 2 and then add it with the second equation. So to understand that, just for you all to recall what happens there. Now you can remember, students, when we multiply Na plus liquid plus electron giving Na liquid, if you multiply this by 2, what happens? We get 2 Na plus 2 electrons giving 2 Na liquid. With that, we add the oxidation, that is 2Cl minus liquid becoming Cl2 gas losing 2 electrons. Now here what happens? There are 2 electrons here, there are 2 electrons there. So when you add them together, you get this equation. What do we get? 2Na plus liquid plus 2Cl minus liquid giving rise to 2Na liquid, that is sodium metal, plus Cl2 gas. So Na plus liquid and Cl minus liquid, that is NaCl liquid. That is the molten or fused sodium chloride. From that, we get sodium liquid, that is the sodium metal, and chlorine gas as the byproduct. So this is the metal that we wanted to extract. Sodium metal in the form of a liquid and chlorine gas is a byproduct. So this is the equation that we need to write. 2Na plus liquid plus 2Cl minus liquid giving rise to 2Na liquid and Cl2 gas. I'm sure you all can remember that from the previous chapter also, students, but just to recall how we balance the equation. So this is what I'm going to write there. So the overall reaction. What is the overall reaction? 2 Na plus liquid plus 2 Cl minus liquid giving rise to 2 Na liquid and Cl2 gas. So that is what you get. You have the two reactions, the cathodic reaction and the anodic reaction. After balancing the number of electrons, you get the overall reaction like this. 2 Na plus liquid plus 2 Cl minus liquid giving rise to 2 Na liquid and Cl2 gas. Is that clear, student? So these are the reactions taking place in the electrolytic cell. Now normally in the lab, when we use an electrolytic cell, we use carbon electrodes. We use a beaker as the electrolytic cell and we use a normal battery, a dry cell, a normal 1.5 volt dry cell, or we can use a 9 volt dry cell depending on the requirement. But when we need to extract sodium in the industrial process, we cannot just use the normal electrolytic cell. They need to have a different cell where it is extracted in an efficient manner. That is what we are going to discuss after this. So in the next slide, here you can see this is the cell that is going to be used and this is known as a Downs cell. So you have to remember the name Downs cell. The above reaction is used to produce sodium metal industrially on large scale. So for a large scale, we need a structure like this. For this, a special type of electrolytic cell illustrated below is used. This is named the Downs cell. So extraction of sodium metal in the industrial scale is known as the Downs cell method. But the reactions that are taking place are the same because we will be electrolyzing fused sodium chloride. So if we try to label the parts of this cell, I will label this side first. So here, this is where we take out chlorine gas. Here we will be taking out sodium liquid. I will label it and then explain it to you. Then we have the negative electrode here. This is the negative electrode and this is going to be a steel electrode. Circular steel electrode. Then we have a circular perforated steel diaphragm. So here this is the circular steel electrode and it is the negative electrode. So you all know towards the negative electrode it is the positive ion that comes and gets reduced. So because of that it is the cathode. So we can write it as the cathode also. So you can say circular steel electrode or circular steel cathode. Either way you can write it. And here also sodium liquid. We can write it as Na liquid or you can even write it as liquid sodium. So either way is fine as long as you all know from what is happening where. So you should know to label the parts of this cell. Then here we have the positive electrode, that is a graphite electrode. So here it is going to be a graphite electrode and here also what is this graphite electrode? It is the positive electrode. Towards the positive electrode the negative ions come and gets oxidized. So because of that, it is the anode. So here, this is the anode. So you can write it as either graphite electrode or graphite anode. Then again on this side also, it is the circular seal cathode, that is the negative electrode, and this is the inlet through which raw materials are introduced into the cell. Raw materials are supplied to the cell. So here, now if you look at the full cell, I will explain it to you all, students. Now this is a cell, you have to imagine it, it is a circular structure. Now in a circular structure, when you cut it across, now this is a complete circular structure, you have cut it across, and in the middle we have the positive electrode, that is a graphite anode or positive graphite anode, that is this. So you have to imagine it like a rod like this. It is a positive anode, graphite anode. Around that, you have these broken lines which I have labeled as circular perforated steel diaphragm. Circular, it is a circle. Now you have the anode in the middle. Around that, you have it as a circle, like a plate, like a not a cylinder, but it is a circular structure around. And that is perforated. You all know the meaning of perforated. There are holes in it, so that substances can move through it. So that is why we don't have a complete plate, then it will block the substances from moving. We need the ions to move. The ions have to migrate. So to facilitate that, it is perforated. There are holes so that ions can move through it. And it is circular. That is why when you cut it, you can see the diaphragm on either side. So you get the circular perforated steel diaphragm that separates the anode from the cathode. So cathode again is a circular structure. So like I said, anode, then you have like a circular perforated diaphragm. Around that you have a circular cathode. That is also made up of steel. So that is why again you see two places there is negative electrode. It is one continuous electrode because we have taken the like a longitudinal section of the cell. You see it in two places. But this is actually continuous. Is that clear, student? So we have the anode, then like a circular perforated diaphragm that facilitates the movement of ions. At the same time, it prevents the mixing of chlorine gas with sodium metal so that they don't react again. Once they are electrolyzed and produced, you get chlorine gas and liquid sodium. To prevent the reaction of liquid sodium with chlorine gas, we have this perforated circular steel diaphragm. Is that clear? So then we have the negative electrode, that is the circular steel cathode. Like I said, since it is circular only, you see it at 2 points. Then here you can see the raw materials are inserted through this. What is the raw material? Sodium chloride liquid or fused or molten sodium chloride, but I will explain it to you all. Now sodium chloride has a high melting point, around 850 degrees Celsius. So that is high temperature, and to facilitate that we will need to supply a lot of energy. So to reduce that and to make it more efficient, what they do is they mix calcium chloride with sodium chloride so that the melting point of sodium chloride is brought down to about 600 degrees Celsius. But the way the percentage of calcium chloride that is mixed with sodium chloride does not interfere with the electrolysis process. Although there is going to be calcium chloride, still sodium will be reduced and sodium metal will be produced and chlorine gas will be the byproduct. So the raw material is introduced through this inlet. It will come into the cell, and from there, the sodium ions will migrate towards the cathode, where they get reduced. And the chloride ions, they will move through this perforated diaphragm and they will enter towards the anode, that is the graphite anode, where they will get oxidized and chlorine gas will evolve from the top. Chlorine is a gas, so it goes up and it will be taken out from the top. At the same time, sodium liquid, that is molten sodium or sodium liquid, is taken out from this outlet. Is that clear to you all? So these are the parts of a Downs cell. The Downs cell that is used to extract sodium industrially. So you need to know the parts, student. So with that, I am going to move on to the next slide. So here, the raw material used for extraction of sodium is molten or fused sodium chloride. That is NaCl liquid. So I explain this to you all. And then you can see here the melting temperature of solid sodium chloride is as high as 840 degrees Celsius. So the melting temperature is about 840 degrees Celsius. By adding about 40% of calcium chloride to sodium chloride, the melting temperature of the mixture is decreased to about 600 degrees Celsius. So from 840 degrees Celsius, we bring the melting point down to 600 degrees Celsius. So there we add 40% calcium chloride. Like I told you all, this calcium chloride does not interfere with the reduction of sodium chloride. Still, the products are the same. So here you can see what will happen if chlorine gas produced at the anode comes into contact with the sodium discharge at the cathode. So this is also something I explained. Chlorine gas is produced, sodium liquid is produced. When they come in contact with each other, they will react quickly and form sodium chloride back. So then the process is not efficient at all. So to avoid that, what do we have? We have the circular perforated seal diaphragm, through which only the chloride ions move towards the anode, where it gets oxidized and it's evolved as chlorine gas. So the cathode and the anode are separated by the steel diaphragm to prevent the mixing of sodium liquid with chlorine gas, so that they don't react again. So sodium and chlorine would react, giving sodium chloride again. This is something you need to remember. Sodium and chlorine would react again and give sodium chloride. To prevent this, the anode and cathode are separated by a steel mesh diaphragm, perforated steel diaphragm or steel mesh diaphragm. So this is also something you need to remember, students. To prevent this, the anode and cathode are separated by a steel mesh diaphragm, and it prevents the reaction between sodium and chlorine to form sodium chloride again. Is that clear? I explained that with the cell also. In this production process, chlorine gas is obtained as a byproduct. That is something you need to remember. Chlorine is the byproduct. And chlorine gas can also be used as a raw material for various products. So we get sodium liquid or fused sodium or molten sodium. That is in the form of liquid sodium metal. That is also needed for many purposes. At the same time, the byproduct, that is the chlorine gas, that is also used for many purposes. So now we will move on to the next slide, where we will discuss the uses of both sodium and chlorine gas. So here we have uses of sodium first. There you can see. Used in sodium vapor lamps which emit a yellow light. That is one use. Then used as a coolant in nuclear reactors in powerhouses producing nuclear energy. And also it is a requirement for laboratory experiments. So these are the applications. Now we have discussed that before also, students, when we discussed the uses of metals. In your previous grade, when we discussed different metals, metalloids and non-metals, we have discussed sodium and we have discussed these uses as well. So sodium is used in sodium vapor lamps which emit a yellow light. Normally the lamps in the streets also, there are sodium vapor lamps that emit a yellow light. So you have to remember that. Sodium vapor lamps. Then it is a coolant. Now sodium liquid can act as a coolant, cooling nuclear reactors. Coolant in nuclear reactors. You all know nuclear reactions are used to generate electricity, nuclear power plants. So the nuclear powerhouses have nuclear reactors where the nuclear reaction takes place and gives out the electricity, where electricity is generated using these nuclear reactions. And that has to be cooled down because there is a lot of heat generated. So to cool down the nuclear reactor, we use sodium. Then it is used in laboratory experiments. Now we have done experiments. You can remember, students. What were the experiments? If you recall, we put a piece of sodium into water where you observe the vigorous reaction of sodium with water. But normally we don't react sodium with acids because it can lead to explosions. In addition to that, to observe sodium, to observe the properties of sodium as a metal, we use sodium. We cut it, it's a soft metal. So like that, we use sodium in the laboratory experiments. So you're familiar with all these uses of sodium. Then in the next slide, I will discuss the uses of chlorine. Uses of chlorine. So here, you can see chlorine is bubbled through water to destroy bacteria in potable water. So here, to destroy bacteria in potable water. So here, we use chlorine to bubble chlorine into water to destroy bacteria. And you can remember, students, potable, P-O-R-T-A-B-L-E. There is a printing mistake in the book also. So it should be P-O-R-T-A-B-L-E. Chlorine is bubbled through water to destroy bacteria in potable water. Because of the nature of chlorine gas, it can destroy bacteria. That is one application. It is used to bleach, that is decolorize, paper, pulp and cloth. Now, if you look at some papers, the old papers or when manufacturing paper, the paper has to be very white. Good quality paper should be white in color. You all know the A4 paper that we use for printing and all. It has to be white in color. So, to get that color, the substance that is used to make paper is somewhat colored. So, that color has to be removed. That is what we say as decolorizing or bleaching. So, during manufacture of paper, we need to decolorize it. For that, we use chlorine. Then there is pulp. Now, you all know plant materials are used to make paper. So, the plant material, when it is made into a soft mixture, that is called a pulp. So, that pulp also should be bleached or decolorized. And then cloths. Now, if you need white cloth, sometimes the cloth that is made might have a color. So, then it has to be bleached or decolorized. So, for all those, we use chlorine gas. So, you can remember chlorine is a byproduct. It is the byproduct near the anode. That is the positive electrode. Here it is the graphite positive anode in down cell. So, there chlorine gas evolves as the byproduct and that can be used for different purposes. Then, production of hydrochloric acid by reacting with hydrogen. Now, when you say hydrochloric acid, you know the chemical formula. HCl aqueous is the acid, but it is produced in the form of HCl gas, hydrogen chloride, and when it is dissolved in water, you get HCl aqueous, hydrochloric acid, HCl aqueous. So, to get that, chlorine needs to react with hydrogen gas. So, that is production of or manufacture of hydrochloric acid. Then we use it to produce plastics such as PVC. To produce plastics such as PVC. What is PVC? PVC is polyvinyl chloride. Now we will be discussing polymers later. Polyvinyl chloride, PVC. Now polyvinyl chloride is a polymer. To produce that polymer, we need something called the vinyl chloride. So they are from the name chloride, you all know the substance, the component used to make polyvinyl chloride, that is PVC, has chlorine in it. So to produce PVC, that is a type of plastic, we need chlorine. So these are the uses of chlorine. Destroying bacteria in potable water, then decolorizing or bleaching substances, production of hydrochloric acid, and also production of PVC, plastic like PVC. In addition to that, you can also remember, students, chlorine is used to clean pools and also to purify water. Not only potable water, even the water that is supplied to the household. To purify that, disinfect that, they use chlorine. And to clean the pools, swimming pools, they use chlorine. So you can remember that as well. So if we include those uses as well, we can say cleaning swimming pools, then we can say destroy microorganism, that is bacteria in water supplied to households. So for these purposes, we use chlorine gas. So now students, we have discussed how sodium liquid or liquid sodium, it is a metal, extraction of metal is done in the industrial manner. That is to produce a large amount of sodium, large scale production of sodium or large scale extraction of sodium using the down cell method. You need to know the reactions taking place there, the anodic half reaction, cathodic half reaction, overall cell reaction, and also you all have to remember sodium liquid is the main product and chlorine gas is the byproduct. And this process is carried out in a down cell. You all need to know to label the parts of the down cell, and also you all should remember that during the process, calcium chloride is added to sodium chloride to bring down the melting point. And also to prevent the mixing of sodium liquid with chlorine gas, a steel perforated diaphragm, a circular steel perforated diaphragm is used. So these are all things or points that you need to remember related to extraction of sodium metal in the industrial manner. And then the uses of sodium and chlorine. So with that, students, I am going to end this chapter, and in the next chapter, we will look at another application of electrolysis.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.